Hi, everybody, and welcome to the third Thursday Science Webinar that we're hosting that's being hosted by the European Marine Board. This is the webinar series that showcases the science behind our publications. My name is Sheila Heymans. I'm the Executive Director of the European Marine Board, and I will be your moderator today. So before we start, just some housekeeping rules. Please make sure that your name is clearly entered so that when we ask questions, or when I read out your questions, we know who you are. Please make sure that you put your questions in the Q&A at the bottom of your screen. If you hover over the bottom of your screen, you should see a Q&A button. Please put the questions in there. And again, if you can put where you're from, that would be really helpful. For technical issues, please use the chat function, and the hosts, the people here at the Marine Board, we will answer any questions we will be able to answer. Please be aware that we are recording this webinar, and it will be made available on the Marine Board website and on our YouTube channel. So just for your notice. So today, the focus of our science webinar is on the critical research needs that we have to inform environmental management of deep sea mining. It builds on the outcomes from our position paper number 22, Delving Deeper, the Critical Challenges of 21st Century Deep Sea Research, which you can download from our website, as well as the policy document that goes with that. Our speaker today is Dr. Pedro Ribeiro. He is a researcher in marine ecology at the Department of Biological Sciences and the Center for Integrated Deep Sea Research at the University of Bergen in Norway. And without further ado, Pedro, I'm going to stop sharing my screen, and you can start sharing your screen and take it away. And thank you very much for doing the webinar for us.
Thank you very much, Sheila. It's a real pleasure to be here. Thank you for the invitation. Let me just share. I believe you can all see my...
Yes, we can.
Yeah.
It's perfect. Thanks.
Yeah, so today I will talk about the critical research needs to enable a science-based environmental management of deep sea mining. It is, of course, a very complex topic. I will try to address as many points as possible, but it's highly complex. What I would say is that there is also a lot of literature out there, and there is work carried out constantly and coming out constantly. It is a topic of great relevance nowadays, and builds on, like Sheila said, some of the science in the European Marine Board's position paper number 22, addressing critical challenges for 21st century deep sea research. I would say this is, among all the critical challenges, this is, I would say, one of the most critical or really relevant nowadays. So as we all know by now, deep sea mining has started as decades ago as an idea that could happen in the future, that we could harvest these mineral resources on the seabed, and right now it is being regarded more and more as a nascent industry. So there are several drivers towards developing a commercial extraction of mineral resources. One of them is, of course, developments in technology that allows us to go to the seabed at 4,000 or 5,000 meters depth and collect these nodules. So this machinery is being developed. Of course, we are on a prototype phase, and there's, of course, still a way to go. But this was one of the drivers. But the main driver that is being advocated for deep sea mineral resource exploitation is the increasing need for minerals to enable a green shift. To enable the development of clean energy technology and be less dependable on hydrocarbons. But of course, there is also the statement that there is a decrease of mineral resources on land, which means that we need to find new sources of minerals. And it's also critical to reduce impact of terrestrial mining. Those impacts on terrestrial, on land of terrestrial mining are well known. On the other hand, the impacts on the deep seabed, even though they are not in the public eye, they are pretty much unknown right now. So the three main mineral resources that we are talking about for deep exploration that are more commercially attractive right now are manganese crusts. They form on seamounts, polymetallic sulfides at hydrothermal vents. So they form from the venting activity and the precipitation of minerals that forms these deposits, or polymetallic nodules on abyssal plains. All of both manganese crusts and polymetallic nodules, they form very, very slowly. It takes millions of years to grow to the size that you see in these pictures. On the other hand, they host valuable ecosystems and vulnerable ecosystems. I can say that, for instance, in the case of the abyssal plain where polymetallic nodules occur, these are the source of hard substrate that is essential for the survival, for the existence of a number of benthic fauna. So if the nodules are removed, that habitat will not be replaced in any time that we can conceive in our mind. So it will take millions of years to be reestablished. So deep sea mining is being considered both in areas beyond national jurisdiction, but also in areas under national jurisdiction of certain countries. I will just briefly address first the case of areas beyond national jurisdictions, so international waters, where the International Seabed Authority is the regulator. So they regulate both seabed mining and the effective protection of the marine environment. They have both these roles, and they are mandated by the United Nations Convention on the Law of the Sea, which establishes mineral resources in the area. So the area is the common name for areas beyond national jurisdiction as common heritage of humankind, which means that they belong to everyone. And therefore they should be managed by everyone. Mineral activities, UNCLOS says that mineral activities must be conducted without causing serious harm to the environment. And of course, this is a term that is not objective in the sense that we cannot quantify. So it is not right now quantified what serious harm means. And this is one of the issues with coming up with environmental management of mining. Several exploration licenses have been granted in the Pacific, on the Mid-Atlantic Ridge, and the Indian Ocean, for these three types of resources. The level of regulations or the level of regional environmental management plans being developed for these different areas also varies a lot. I would say that they are slightly more advanced for the CCZ, which is this yellow polygon that you see on the Pacific Ocean. That's where the nodules, polymetallic nodules, occur in more abundance. So as you see, these license areas are quite widespread throughout the world's oceans. The current status regarding regulations is the following. There are draft exploitation regulations, so to start commercial mining, and draft standards and guidelines under discussion. And the last meeting at ISA was, if I'm not mistaken, end of March or start of April, where there was a discussion about these documentations, and a number of revisions were recommended. So this is a process that has been going on for a while now, in order to improve the state of these regulations and the way that they can predict and that they can determine all the mining activities. There are also regional environmental management plans under development. And like I said, this is slightly more advanced on the CCZ in the Pacific Nodule province, but they are also being developed for other areas, including the Mid-Atlantic ridge. One important aspect that came up relatively recently, it was last year in mid-2021, that Nauru is a republic in the Pacific, triggered what we call the 2-year rule, which means that after triggering this 2-year rule, the ISA has to accelerate the completion and adoption of regulations. Otherwise, the contractor that is being sponsored by Nauru can submit a plan of work for exploitation, and this plan of work would most likely be provisionally approved under the light of the state of the regulations at that time, which means that it's pretty much a process that once is set in motion, cannot be stopped. As I work in Norway, and I am quite familiar with the opening process for mineral exploitation in Norway, I would like to talk a little bit about that. So Norway has published the Seabed Minerals Act in July 2019. So this act entered into force. And it's an act that relates to the mineral activities on the Norwegian continental shelf. And the Norwegian continental shelf is essentially the deep areas of the extended EEZ of Norway, where these deep sea minerals occur. The Act establishes principles for mineral exploitation in agreement with environmental, economic, and societal goals, and determines the different phases of the activity. But these phases, these are not described in any detail, and this is, I would say, work that has to be developed in the near future. It also stipulated, and this is the most important for now, an opening process for seabed minerals. So the opening process essentially is led by the Ministry of Petroleum and Energy. So they will be the regulators. And the Norwegian Petroleum Directorate is an agency that is mandated by the MPE, by the Ministry of Petroleum and Energy, to conduct the impact assessment study prior to opening any mining activity. So it's an impact assessment study that is going on right now based on current knowledge, but also includes the mapping of mineral resources in this area. And as you can see on the map, the area in light brown or orange is what we are considering. This is an area of nearly 600,000 square kilometers that is dominated by the Arctic mid-ocean ridge. And this is where we have hydrothermal vents. This is where we have also seamounts that are potential candidates for hosting manganese crusts. So crusts and seafloor massive sulfides are the mineral resources, the mineral deposits that we are considering here in areas under Norwegian jurisdiction. We do not have, as far as we have explored so far, there are no polymetallic nodules here. It's a very rugged topographic area that is, like I said, dominated by this by the ridge. So it's a completely different setting from an abyssal plain where the nodules form. In parallel, or just recently, after this process has started, there was a proposal to establish a particularly valuable and vulnerable area, which in Norwegian has the acronym of SVO. I will spare you to say how it is said in Norwegian. For the Mid-Atlantic ridge, so it's the area NH4 within the Norwegian EEZ, and it establishes these areas and it proposes these areas as valuable and vulnerable on the basis that it hosts abundant endemic and unique fauna. So we are talking about vent fauna specifically, but also seamounts in this area host species that are endemic to the Nordic seas. It's an area of high productivity where spawning and rearing of slow-growing fish species also occurs. In terms of benthic communities, these are established as very, very vulnerable. They are classified as very vulnerable, with limited or no capacity to recover. This information is based on expert opinion and very few studies conducted in the region, and of course, literature, international literature that describes deep sea fauna as being generally vulnerable, slow-growing, so vulnerable to disturbance. This initiative may eventually lead to establishing some of these areas as protected, but this process has not started yet. So the impact assessment study conducted by the Norwegian Petroleum Directorate has been on public consultation. This program has been on public consultation. It has several steps that I will explain later. And it has received comments from numerous institutions and research agencies in Norway. Comments regarding what we consider to be shortcomings of the program or points that should be addressed. And all these comments will be incorporated in the final impact assessment report that will come out next year. Also adding to these comments, there was a number of background reports on different aspects of the knowledge base that needs to be gathered for this, to make this decision regarding, for instance, the seafloor environment, the pelagic ecosystem, technology, etc. And this is based on, like I said, current knowledge. And you will see from the timeline that was established for this opening process that there is very little time to collect any new information. So the timeline, you can see that it started with the coming into force of the Seabed Minerals Act. There was a series of procedures. So you can see in green what has been done so far. There was the background information published and under public consultation. Also, the further studies that are being conducted to predict possible impacts. They are being conducted based on current knowledge. Again, there is no time to carry on the studies that would be needed to close some of these gaps. There will be a report coming out at the end of this year, and it is predicted that there will be a decision by the Norwegian government, by the parliament, whether or not the Norwegian continental shelf will be open for mining activities in June 2023. So it's just 1 year from now. So as you can see, the timeline is quite short, and it is pretty clear that there is not enough time for new studies within this time frame. And it's of course a very complex exercise to try to understand all the possible impacts of deep sea mining. I put a scheme here that was published on the World Economic Forum report that came out in April. I think it's a really commendable exercise that shows all kinds of impacts from environmental to effects of metal availability, effects on ecosystem services, effects of new mineral resources, revenue, and the level of predictability that we have about these potential effects or potential impacts. In the rest of this talk, I will only address the lower slice of the diagram. So I will only talk about environmental effects. and the knowledge gaps that prevent us from understanding what those effects will be. So what are the knowledge needs for environmental management? They can be divided, in my opinion, in three broad categories. We need to have a characterization of the natural environment. So we need to have a baseline. And this has to be done before any disturbance is induced in the ecosystem. We need to also have a quantification of the potential mining impacts. It's not just establishing what the impacts might be, but also quantify, so to conduct predictive studies, modeling, to try to quantify, to put boundaries, numbers in the effects on the environment, potential effects. And there is also the need to develop effective monitoring and mitigation strategies. And these are not talking specifically about monitoring. It's not an easy exercise to set up a monitoring system in such remote areas that can, in near real time, provide information to decision makers that can then take action in order to take adequate action to minimize impacts. As you can understand, this requires collecting data from these depths and from the middle of the ocean and transferring them to shore, and they have to be processed, and there has to be easy access to the results. The data needs to be analyzed quite quickly. So it's not an easy goal. So I will just talk a little bit in detail about what are the requirements of an environmental baseline. So of course, first we need to understand the oceanography of the area where mining is taking place. We need to understand currents, temperature, turbidity, etc. So we need to have a good characterization of the water column and the currents regime around the area. We also need to understand what are the seabed properties in terms of topography, morphology, the geochemistry, all in the natural state. And this is the part that I am more dedicated to as a deep sea biologist. We need to understand community structure of these deep sea areas. These are remote areas. Research, surveys, exploration, and quantification of abundance and distribution is essential to have a good overview of the composition and the distribution of these different habitats. Of course, we need to cover the different sizes of organisms, from microbes to megafauna. There has to be a huge effort from taxonomists because many of the species that we collect are new to science and they need to be described. And at the same time, there has to be, we have to develop methods for more rapid assessment of biodiversity, which usually include DNA, for instance, DNA barcoding analysis, or eDNA metabarcoding, or metagenomics. So this is quite a daunting task, and the level of sampling that we have seen so far, despite a lot of research being done recently, and you know, there's more and more research programs for the deep sea. It's such a huge area and heterogeneous area that we are considering, that it of course takes a lot of time, and it takes dedicated experts that can give us an account of the biodiversity present in the deep sea. In addition to that, we need to understand how the different communities, how the different species in the community are interconnected, how they interact. We need to study the ecology, so how they interact between them and with the environment. It's particularly relevant to understand species interactions. For instance, if there is one species or one group of species that is particularly sensitive to environmental disturbance, we need to understand what would be the consequences on other species. We need to understand how the deep sea species adapt and what are the abiotic drivers for the species to adapt and to thrive in the deep sea, so that we also understand if there are changes to the environment, what would be the consequences on those organisms. One of the most important aspects to consider, I mean, I consider them all important, but connectivity is particularly important to understand how a biological community that is under disturbance by, for instance, deep sea mining in this context, will be able to recover from, once the mining operation ends, recover from recolonization from different sites that were not subject to mining. And we usually take two approaches. We take dispersal modeling, so we model the dispersal of animals and particularly their larvae, and we also use population genetics, and this can give us this assessment of whether the communities are connected, which means the different populations are connected, which means that one population can provide colonizers to another population, or whether they are isolated. And this of course has very important implications for management. We need to understand biogeographic patterns so that we know whether or not the local extinctions are actually more severe in terms of regional or global extinction. So we need to understand biogeographic patterns very well. And for the deep sea, in certain areas of the deep sea, this is not something that we can assess right now. And of course, we need to understand the ecosystem functions and services that derive from the functions of these communities. We need to understand, for instance, how a reduction in productivity can lead to impact on fisheries, for example, and what level of reduction we are talking about in this ecosystem function and the consequences for the services of these deep sea ecosystems. I also give the example of bioprospecting. We don't have a clear picture or a complete picture of what would be lost in terms of bioprospection, biomaterials or biocompounds with the extinction of part of the biodiversity that is associated with mineral deposits. And of course, critical to all of this is to measure natural variability, both in space and time. And this is a challenge that is being addressed right now using more and more autonomous observatories, landers that can record the environment and how the community evolves through time with continuous data, instead of just visiting the same site once a year and collecting only point samples. So measuring this natural variability and being able to contrast it against possible disturbance is the way, it is the only way to detect an environmental impact. So speaking about environmental impact, I will also briefly address what are the requirements or the topics that are, in my opinion, most important to understand, for us to understand. There is, of course, the potential impacts of mining, which necessarily will involve removal of habitat, of the habitat that is associated with the deposits, but also the generation of sediment plumes, either the excavation or the drilling plume, but also the plume that can be generated in the water column from the discharge from the discharge water once the material comes to the surface and is sorted, and then there is discharge water. But we also know that the deep sea is a very, well, it's dark, and as far as we know, not very used to intense visible light and to intense noise. So we need to understand what are the impact of this machinery in terms of noise and light. And this is a challenge because many plans for mining machinery are actually confidential, or they have not been made public by mining companies. And in my opinion, it is the only way to predict impacts, is to have an insight on the mining technology and operations. And of course, we need to understand what will be the cumulative impact from multiple sources. So imagine deep sea mining impacts combined with climate change effects, or even the cumulative impacts of several mining operations operating in the same area. We also need to understand what is the natural ability of the ecosystem or of the impacted habitats to resist the disturbance or to recover naturally. And there are also efforts, research efforts to understand and to develop restoration approaches. So it's assisted restoration. So the picture that you see on the left is a colonization experiment with artificial nodules on the CCZ to understand if this would be a viable restoration approach once the nodules are extracted. And of course, for management and monitoring, this is also a huge goal and challenge. And this is, we are also short on defining what are the indicators to monitor, what are the boundaries, the values that we consider normal, and the values that we consider outside normal variability. There are no standards and guidelines developed so far. And monitoring systems need to be developed. As I said, this is a technological challenge. And there are programs, in particular at the EU level, to develop such systems that can monitor in real time and give the relevant information in near real time. So in summary, in areas beyond national jurisdiction, what is the knowledge level that we have? Well, this depends on the type of resource. You can see that in orange, knowledge about active sulfides, it's, well, green and dark green are better knowledge than white, is the most well-known ecosystem. But you see many areas in white, and all these areas indicate areas for which we don't have any sort of information that will allow us to provide to recommendations based on science for management. In the Norwegian case, and I will focus here on the benthic habitat. This is where I work, and I feel more at ease talking about this. In the Norwegian case, as you can see, there's still a lot to be done. In terms of basic knowledge, we are still at the sampling level. So we are collecting samples that will allow us to conduct most of the studies that are needed, but we need time. We require time. The scientific community requires time to conduct these studies. And perhaps it's time that is also needed by the mining industry to develop mining technologies with minimal footprint. Environmental footprint. So I would not consider the time that is needed for these studies to be limitative to an opening process for seabed mining in Norway. So just to wrap up and to talk a little bit about how some of these knowledge gaps are being addressed in Norway. There are several projects going on, and at UIB, we are coordinating a project that is addressing knowledge gaps about benthic deep sea ecosystems in Norwegian waters. And this is a program that will run for another 3 years. And we expect to be able to answer some of the questions and some of these red and yellow areas that we see here in the current knowledge status. So to summarize, and this is my last slide, in my opinion, seabed minerals, they co-occur with fragile deep sea ecosystems. So mineral extraction needs to take this into account. There are science gaps that do not allow us to provide sound recommendations for environmental management of deep sea mining right now. And it is essential that we close these gaps, but it will take time and it will take research effort. In a recent paper by Diva Mon, there was a consultation of experts and to experts and stakeholders that indicate anything from a few years to 10 years or even more as the time needed to collect enough information that will allow us to develop a good management plan. And of course, collaboration among stakeholders is crucial. And I believe that we need to be able to work together and share information. It is not possible to close or put together all the pieces of the puzzle without everyone being around the table and working together towards the same objective. Thank you.
Thank you. Thank you very much. Thank you very much, Pedro. That was really great. It gave us a good overview of where we stand at the moment. I see that we have one question so far from our attendees, and that's from Francois Lallier. Hi, Francois. Nice to see you, even if I don't see you. The question he's asking is whether the documents that come from Norway is available in English, and if so, if you could share links for those with the people online. If they are, then maybe you can put the link in the chat.
Yeah, they are available. They are in Norwegian, unfortunately, but it is possible to translate, and I'm happy to put the link in the chat. I can do that right away, of course.
Oh, thank you. And then while other people think of their questions, which always happens, people were probably so blown away by the beautiful pictures that they haven't really thought about it. I will start off by saying, what do you think is the minimum that's needed to try and manage this responsibly? You know, if you had to say you need 5 years of research, or do you think 10 years of research, what would be the minimum requirement, do you think?
Yeah, I have been asked this question before, and in my perspective, if we want to understand seasonal variability is one thing, but if we want to understand interannual variability of all those parameters that for which we need information, I would say anything between, well, no less than 5 years, and anything between 5 and 10 years. And the reason why I say no less than 5 years is because I know, and my colleagues also know, that it takes time to collect the data. It takes time to organize these campaigns, collect the data, bring the technology together, collect the samples, and have experts. And I'm not talking only about numerical analysis now. I'm talking about taxonomy as well. We need experts to be able to look at these samples. So there's really not an easy solution, and I'm afraid that easy approaches, or not easy approaches, beg your pardon, more practical approaches may be shortcuts in themselves, because they also need validation from other techniques. And I give the example, for instance, of eDNA surveys. eDNA surveys can be, and they have the potential to be a quick and efficient method of biodiversity assessment. However, they have to be based on a sound database of taxonomy, of what the species that we know exist there. Do we need to know everything? No, but we need to have reliable, solid, robust indicators. Mm-hmm. And I do not advocate that we need to know everything down to the absolute detail, but having reliable indicators is essential.
Yeah, thanks. Then Francois also has another question. Do you have an idea of the inactive versus active vent systems on the Norwegian ridges? and on their respective communities. So how well do you know what the communities are on the ridges, and whether they are active or not?
So yeah, we are talking about hydrothermal vents.
I'm assuming so. Yeah.
Yeah. Okay. So on the Arctic mid-ocean ridge in Norwegian, under Norwegian jurisdiction, we have two sections that have different levels of exploration. So the Moon's Ridge, the southern section of the ridge that is on the Norwegian EEZ, has been target of a research plan in the last 10 or 15 years. So it's reasonably well mapped. We believe that most of the vents have been discovered there, but we still have a couple of candidates. On the Knipovich Ridge, just further north, the exploration is just starting. So this is one point. Part of the ridge has not been explored, even at biological, even at mapping, mapping level. And the second aspect is to understand exactly what is active and what is inactive. I think between active and extinct, there's a big distance, literally speaking, as the vents are transported away from the ridge axis, they become extinct, and eventually they are buried under sediment. But we do have vent fields where we can see active chimneys, so focused venting, and inactive chimneys, hosting a completely different fauna within a few dozen or a few hundred meters. So the status of what is active and inactive, it's also not so straightforward.
Yeah. Okay, and then I see that Beth, hold on, I think, hold on, Beth Urquhart put a question in the chat asking, what is the social license for deep sea mining in Norway? Does society think mining could be environmentally friendly?
Well, if I have to say that if there's a country where this process can, out of knowledge, it's not out of thinking that this is the best, but I know the reality. If there's a country where I think the process can be conducted under the auspices of seeking social agreement, social license, it could be Norway. Of course, we try to inform the public as much as possible. Me and other colleagues, we participate in public events where we try to engage with the public, and many of them are really surprised to even know that there are animals down there, that there is fauna down there, because I'm talking about the vents right now. We do not have these exuberant communities that we see in other ridge systems. The fauna is quite smaller, and but it is there. There's a whole community living there. So that's the first point, is to show the public that there are actually animals there, and that the deep sea carries out important functions that are also highly beneficial and highly needed for us. So I believe that it will take some time, but the Norwegian public is highly wired into seeking this information, and I think that this social license will be needed. In order to develop or to carry out, to start commercial mining in Norway. I think it's a point that it will have to be essential.
Okay, then we have a question from Arne Meinvold, who asks, when you say at least 5 years are needed, for this, is it before exploration or exploitation? And then I want to add to that question, when you say you need 5 years, do you, because I know how long it takes to sort out a project to go and actually look at these things. So does that also include the time to get the money to go? So in reality, is it 5 years from the moment you have the money and have the boat and can go? And then is that you need, no mining for the next 10 years because it's going to take you that long? So that those two questions sort of are convoluted in a sense.
Yeah, that's an excellent question. I was considering 5 years of actual research and data analysis. What I say is that there are all the motives. And now forgive me for focusing a bit more on the Norwegian case, which is a case that I know a little better. I work more closely with it. There are all the motives, all the reasons to develop research plans that can address these matters. The technology is there. We have excellent scientific capacity. We have excellent ocean industry with many years of experience in ocean activities. So I would say, and my 5 years is just my opinion, because I know, and speaking as a biologist, maybe a colleague from geophysics has a different opinion, or but speaking as a biologist and knowing some of the challenges that involve engaging the right people into this. But like I said, the project that we are running, and it also includes industry partners. It's a 3-year project, but we have very defined goals. But we are not starting from zero. It builds up from previous activities from all the partners. But I would say, in an ideal scenario, I would say that 5 years would not be excessive for the time that we need. And addressing Arne's question, well, it depends how exploration is done. I am an advocate that exploration that involves operations on the seabed, I'm a benthic biologist, should be also subject to some kind of impact assessment, which means that those activities, and for instance, testing machinery, test drilling, we can argue that depending on the scale and the location of these tests, they should also be subject to some kind of impact assessment, which means that some background information, okay, maybe not for the whole region because we are talking about smaller studies, but some background information would be essential, in my opinion, to get the green light for small scale exploration studies.
And following on from that, actually, do you think that it would be critical for the data that came from any mining to be open to, open access? If you consider the seabed belongs to all of Norway, if we talk about the Norwegian case, all of the people living in Norway, do you believe that the data that any data that comes out of the mining should then be open access?
Well, I believe so. I believe that there should be a legislation put in place that assures transparency, in the sense that data should be shared or should be made available to the public. And are we talking about the exploration phase or the exploitation phase?
Well, both, in my opinion, both. Yeah.
Yeah, I think the data should be made available to the public. It should be public.
Yeah. And then in the chat, I see Britt, one of the Marine Board science officers, asks, are there already some results from the assisted restoration experiments? And what is the restoration potential for the polymetallic nodule, seamounts, and vent ecosystems?
These settlement panels have been deployed. So as far as I know, there are no conclusive results yet. The question to place here, from my experience again, hard substrates in the deep sea, they tend to be colonized by fauna that depends on hard substrates. It is always a matter of choosing, if we want to optimize the colonization, of choosing the right material. However, the matter here is whether the scale of restoration that we are considering, whether or not this is feasible, for instance, in the case of polymetallic nodules, the geographic scale of what we are considering here. That's another point. I would say, without having a crystal ball, that such restoration approaches have the potential to enable settlement of this benthic fauna, and in that area, talking at least on the megafauna, we're talking about sponges and small corals that live there. I don't know about microbial communities, but I'm really looking forward to the outcomes of this study. I think it will be very, very interesting. And I know that there is a project that will look into restoration in the deep sea more closely, that has just kicked off, and in which I am also involved. I think it's a very, very important issue to address.
And then finally, I don't know, maybe you won't know the answer to this, but because it's about the plumes and the physical processes of moving all of, depending on how the mining takes place, there will be big plumes of sediment that, given the physical properties of the deep sea, could really move a long way and stay in the water column for a long time. Do we have any idea of how long it might take for the water to settle down so that settlement of larvae can happen again? Do we have any information on that kind of processes?
Well, it depends on the area. So there has been, I think, where the studies are more advanced again are on the nodule province of the CCZ, where an actual mining plume during a mining pilot test was tracked, and it was possible to see that it does travel quite a long way. But of course, as the distance, the density of particles becomes, so the particles become, the plume becomes less dense. There are no studies on the long term, or even not so long term, but impact of these plumes. We are at this point predicting that where the plume covers the seabed, it all depends on the thickness of the plume. What I would like to highlight is that we have to look at the different mining resources as different activities. So, for instance, if we are considering drilling for seafloor massive sulfides, some of these old extinct deposits, and I'm also only considering drilling, that drilling will take place in extinct deposits, they are usually buried under sediment. So there are, of course, plans from different industries to different companies to create mining machinery that can drill through the sediment and extract the mineral, the sulfides, in a semi-closed or in a closed system. And some companies also advocate that it is possible to create a system that, so it means that the mining plume will be minimized. But there are companies also advocating that it will be possible to eliminate the discharge water, or to calculate the distance at which this discharge water is released to minimize the spread of the plume. But we don't know, for instance, what are the consequences in terms of smothering of filter feeders or toxic effects on fauna. These studies have, by and large, they have not been conducted. But there is, I would say, a concern from the industry to try to build and to conceive this machinery that minimizes either the impact of drilling or the impact on the seabed, the contact on the seabed. But these are just, as far as I know, still concepts, and they have not been developed. The only machinery that I saw being tested is in contact with the seafloor, and it's a crawler. So, so we could be talking about effects of plumes when in fact the plume will be much smaller or will be much larger. And that's why it is important to know exactly what kind of mining operation will take place to be able to model this. But we can also model different scenarios and to have kind of a minimum and maximum boundary of what we expect the spread of the plume to be.
Thank you very much. Well, I don't see any other questions in the Q&A nor in the chat, but I think it's been a super interesting presentation. Thank you very much. It was great to hear and to see the beautiful photos that you have and videos. And now I think I will just share my screen and remind everybody that our next webinar will take place. Let me just take that away. Will take place on Thursday, the 16th of June, same time, same place. And we will have Per Newjahr, who's also from Norway, talking about the development in research vessel capacity and technology, which is based on our document on European research vessels. So if you're interested in research vessels, which I think most people will be, you are more than welcome to join us then. And actually, I think there's one more question from Francois. He says that we should recycle metal so that we don't need to go into the deep ocean. I agree with you, Francois. So thank you very much to Pedro, and I look forward to seeing you all again next month, same time.